Good afternoon, ladies and gents. Today we are going to look at the AS paper 2 from a May-June sitting 2014. This paper allows you to have 1 hour 15 minutes to complete it. I hope we're going to be able to complete it within less time. Okay, let's jump right in and start with the first question. The question reads, solve the equation for absolute value of x plus 2 equals the absolute value of x minus 13. Okay, let's start with that immediately. So question 1 is solve for question 1I. Absolute value x plus 2 equals absolute value x minus 13. Well, we know that we can square both sides of a bracket. That would give me x plus 2 squared equals x minus 13 squared. So x squared plus 4x plus 4 equals x squared minus 26x plus 169. Okay, now let's quickly solve. X squared and x squared will cancel one another out, and plus 26x will give me 30x equals minus 4, give me 165. I divide on both sides by 30, so x will be 11 over 2, and we're done with that question. Okay, so for part 2, they ask us now, hence solve the equation y, 3y plus 2 absolute value equals 3y minus 13 in absolute value signs, giving your answer correct to 3 significant figures. Okay, so we can see that y, 3y plus 2 equals 3 to the power y negative 13. This term is in the place of an x here. Thus, I can use this answer of x and then set it equal. So we know that 3 to the power y would be equal to 11 over 2. So to solve this, I will take the natural log on both sides. Okay, use the power rule and then solve for y. Okay, now this answer is a bit mushy at the moment. We can use our calculator to just simplify it because they say to 3 significant figures. So I get 1.55 for my answer there. Okay, good. So that's the conclusion of question 1. Let's move on to question 2. Question 1 was worth 4 marks, 2 for part I, 2 for part 2I. Question 2. Okay, solve the equation 3 sine 2 theta tan theta equals 2 for the interval between 0 and 180 degrees. Okay, so give you the question. There they go for question 2. And now we're asked to do that. Okay, my first step is to look at this tan. Okay, tan can be and sine 2x or sine 2 theta. So let's have a look. Sine 2 theta would be 2 sine theta cosine theta. That will already make the thing a little bit easier, and we know that tan is sine over cosine. So let's rearrange it, just rewrite it. So 3 2 sine theta cosine theta. Tan is sine theta over cosine theta equals 2. Okay, now it seems like we're going to go someplace that we like. Cosine and cosine can cancel out. Sine and sine can square, will be sine squared. And here we have 6. So 6 sine squared theta equals 2. So sine squared theta equals a third. And now we can just take the square root on both sides to simplify this. Square root, so sine theta equals plus or minus the square root of 1/3. Okay, so now we use that idea to find theta. Sine inverse of 1/3 or square root of 1/3 equals theta, or sine inverse of negative square root of 1/3 equals theta. If I find theta there, it is 55.3 degrees. And here we have theta equals negative 35.3 degrees. But this answer is not within our required interval. If, however, I add 360 degrees to it, it would also not be within the required interval. So let's use another property of sine. Sine 180 degrees minus theta equals sine theta. That would give me 180 degrees minus 35.3 equals theta. So theta must also be equal to 144.7 degrees. Okay, good. So we're done with question 2. Yes, 4 marks. Okay, and thus theta, let me just state it because maybe it's not so clear that I've stated. Thus theta can only be the 2 roots 35.3 degrees or 144.7 degrees. That's my only 2 solutions. Okay, good. Let's move on to the next question. Question 3. Okay, there we go. Let's read the question together. Question 3 asks us to find the integral of 4 cosine 1/3 x plus 2, and the B part is to use the trapezium rule. So let's focus on the A part first. Okay, let me copy it here on my workspace. The integral of 4 cosine 1/3 x plus 2 dx. Okay, if I need to take the integral, we know that we can pull down that 4 to the front, so it's actually sort of eliminated. I don't have to worry about it. The integral of cosine is sine. My inside of my sine function will stay as it is, times 1 over the derivative of the inside, so it would be 1 over 1/3. Okay, plus my constant c. Let's simplify this. 1 divided by 1/3 would give me 3. 3 times 4 would give me 12 sine 1/3 x plus 2 plus c. And that is my final answer. Okay, good. I'm quite happy with this one. Let's move to question B. So 3b. Use the trapezium rule with 3 intervals to find an approximation to the integral of the upper limit 12, lower limit 0 of a square root of 4 plus x squared with respect to x, giving your answer correct to 3 significant figures. Okay, let me copy the question down. Integral 12, 0, square root 4 plus x squared dx. Okay, good. So we want to find the trapezium rule, so we know that h equals b minus a over n, and n is the number of intervals, and they say it needs to be 3 intervals. N equals 3. So b is my upper bound value. That would be 12 minus 0 over 3, and that would give us a result of 4. Okay, so my h is 4. I can just use this little space up there, move it back. Okay, and we know that that would be 0, and that part would be 12, and it's 3 intervals. So 4 plus 0 would give me 4. 4 plus 4 would give me 8. 4 plus 4 would give me 12. And there's my x value. So x0, x1, x2, x3 value. Okay, now we need to use the trapezium rule. So we know that when x equals 0, oh, x0 equals 0, then my y value would be the square root of 4 plus a 0 squared. And that would give me an answer of 2. Okay, and when x1 equals 4, y1 would be 4 plus 4 squared. That would give me an answer of 16 plus 4 is 20, so square root 20. x2 equals 8, so y2 would be 4 plus 8 squared. 8 squared is 64, plus 4 is 6, square root 68. Y3 would be 12, so y3 would be 4 plus 12 squared is 144, plus 4 would give me 148. Okay, so we've got the values. Now we can string up the equation for the trapezium rule. So it's a half h. H is 4, curly bracket. My x0 value is, my y0 value is 2, plus square root 148, plus 2 times my middle terms, and curly bracket. This I can use my calculator just to find the answer. So this is the integral of with an upper bound of 12 and the lower bound of 0. So this would be the area. Remember, this trapezium rule gives us the area, and my final answer, if I do quickly tap it into my calculator, would give me 79.2. And that is with correct, and they asked us correct to 3 significant figures. 1, 2, 3, so 3 significant figures. Okay, good. So that was question 3. Let's move on to question 4. Question 4. Oh, I love parametric equations. They are so much fun. Okay, let me move it up a bit. Okay, the parametric equation of a curve are x equals 2 natural log t plus 1 and y equals 4 e to the power t. Find the equation of a tangent to the curve at the point which t equals 0. Give your answer in the form ax plus by plus c, where a, b, and c are integers. So we've got to do, let me copy the question down first. Question 4. And we are given x equals 2 natural log t plus 1 and y equals 4 e to the power t. That's the two equations. So I'm going to, and then the parameter is t. So I'm going to find dx dt. That would give me 2, the integral of a derivative of natural log t plus 1 would give me 1 over t plus 1, and then for dy dt here on this side, 4 e to the power t is e to the power t, and we are done with taking the derivative of these portions of a function. Now to find the x dt, dy dt equals the x dt divided by, look at me, the y dt divided by the x dt, and we can just quickly simplify that. 4 e to the power t, I'm just going to do it times t plus 1 over 2, that, let me move it up, okay, that would give me 2 and 2 can cancel out there, it gives us 2, so it would be 2 e to the power t plus 1. Okay, so that would be my dy dx. I'm really not doing a good job here. Okay. Okay, so I hope I'm going to concentrate a little bit better there and don't make mistakes. Okay, so we need to find the gradient and we need a point. So the gradient is now easy. We know that they've asked us for the point where t equals 0. So we're going to, when t equals 0, my gradient would be 2e0, 0 plus 1. That would give me 1. That would give me times 1. So it would be actually just 2. So my gradient is 2. So, but I still need a point, but I do have a x value, and we're also going to use it when t equals 0. So my x would be 2 natural log 0 plus 1. That would give me 1, the natural log. So the x value would be natural log 1 is 0, so that would give us 0. And my y would be 4e to the power 0. So y would be 4 times 1, that gives us 4. So this point that I need is 0 and 4. Okay, so I've got a gradient. I have a point. We can find the equation y minus y0 equals mx minus x0. So we can actually write there equation of tangent. Okay, and now simplify or substitute those points in. Y minus 4 equals 2x minus 0. That would give me y equals 2x plus 4. Okay, we want it in the form ax plus by plus c. So it would be 2x minus y plus 4 equals 0. And there is question 4 done. 6 marks. Okay. Just a little bit careful there that you don't make these silly mistakes that I've done there. Concentrate. Okay. Question 5. Question 5 is a straight line on a natural log axis. They ask us the variables x and y satisfy the equation y equals k to the power px, where k and p are constants. The graph of a natural log against x is a straight line passing through the points 1.35 and 1.87, and also through 3.35 and 3.81. As shown in the diagram, find the values of p and k correct to two decimal places. Good, so we know that this would be an exponential function that's drawn against a natural log giving a straight line. So we need to use some of those rules involved there. This is question 5. Okay, so we are given y equals 2px. We know that we need to take the natural log on both sides. So natural log y equals natural log, what did I do there? Skip the k. K 2px. Okay, so we need to use the product rule there. Natural log y equals natural log k plus natural log 2 to the power px. Okay, use my power rule to bring that in front. Natural log y equals px natural log 2 plus natural log k. So I just swap those two terms around there. That would give me it in the form, okay, let me see why I did that. Y equals this is mx plus c. So m are the two ones that I've circled, the p and the natural log 2. Okay, good. I know how to find m. M is delta y over delta x. The change in y over the change in x, I can use that to substitute. So my values 3.81 minus 1.87. My two y values I subtract over the two x values that I need to subtract. Okay, use the calculator and I get 0.97. Okay, so that's my m. Now they ask us to find p and k. P, I can find that because m m is p natural log 2. Okay, so I have 0.97 divide by natural log 2, that would give me p. And we have p equals 1.399, and we need to write it to correct to 2 decimal places, so p would be 1.40, correct to 2 decimal places. Okay, good. So we are happy that we found p. So now the next step is to find natural log, or to find k actually, not just natural log k, but to find k. I have values for natural log y, and I have a value for k, for x, and now I do have a values for this p, or natural log the m, the gradient, so I can just simplify that. Okay, so we have, let me just rewrite the equation. Natural log y equals p x natural log 2 plus a natural log k. That's what we found. We know that the gradient is p and natural log 2, and you know what the gradient is. It's 0.97. I'm just going to use that. Natural log y, I can use any one of those points. So let's just go for 1.87 equals 0.97. Remember, that is both those values together. X, and x is 1.35 plus a natural log k. Okay, and now just solve here. I subtract the two from one another, so natural log k equals 0.5605. We know that we can write that in exponential form. Natural log is just the same thing as e, so e to the power, or log e, log base e, so e 0.5605 equals k, and I can use the calculator to obtain that, so k is 1.75, correct to 2 decimal places. Okay, and question 5 is done. That was worth 6 marks. Okay, let me just turn the page here, save some paper. Good. Question 6. Question 6 is also one of my favorite questions. I love paper 2 for AS Mathematics. It's really a fun paper. If you know your work, you can score good marks with it. So here we have a polynomial px is defined by x cubed plus 2x plus a, where a is a constant. Given that x plus 2 is a factor of px, find the value of a. So here we can use the factor theorem. The factor theorem is, if I set x plus 2 equal to 0, my remainder of my px function would be 0. So let me quickly do it for you guys. So we know that x plus 2 is a factor. Okay, so I set x plus 2 equal to 0, so x equals negative 2. If I substitute that negative 2 into my polynomial, I will get 0 by the remainder theorem. So we're going to use that principle. So 0 equals negative 2 cubed plus 2 negative 2 plus a, because that's my polynomial, and I can simplify that. So 0 equals negative 8 negative 4 plus a, so a seems to be 12. Okay, and that's the first part, and that's worth 2 marks. Okay, part 2, they ask, when a has this value, find the quotient of px when it is divided by x plus 2, and hence show that this polynomial has exactly one root. So we have x plus 2, and we're going to divide it by our polynomial when a has this value. So x cubed plus 0x squared, this is just a placeholder, plus 2x plus 12. I can quickly do the division here. So x squared, so x cubed, I just multiply, plus 2x squared, subtract, That would give me negative 2x squared plus 2x, negative 2x. X times x would give negative 2x squared, negative 4x. Subtract, that would give me 0. That would give me 6x. Bring down the 12. Let me just move it up. Sorry. That gives me positive 6. Multiply. 6 times x is 6x. 6 times 2 would give me positive 12. Subtract, that gives us 0. So here I have my answer. So I have x plus 2 and x squared negative 2x plus 6 as my two possible factors. But now let's see, can we possibly factor this bit? Okay, so to prove that we only have this one root or only have one solution, we can't just try to factorize that and say it's impossible. Let's use something that is constructive. Okay, the b squared negative 4ac, our discriminant. We know that if a discriminant is going to be smaller than 0, then there will be no root. So let's substitute. So negative 2 squared, negative 4a is 1, and the value of c is 6. That would give me 4 minus 24. Well, this is definitely negative 20. So we can state b squared negative 4ac is smaller than 0, thus no roots. Okay, so that's my only root. My conclusion, my only root would be where my only root is x plus 2. Okay, good. So that was that was question 6. Let me just check that I've done everything there. Yes. So there's exactly one root. Okay, let's move on to question 7. Okay, question 7 is integration question. Okay. It is given that the integral of with upper bound of a, lower bound of 0, a half e to the power 3x plus x squared with respect to x will give me 10, where a is a positive constant. And then they ask us actually to find the value of a, and they give us some form in which a must be. A must be in the form a third natural log 61 minus 2a cubed. Okay, so let's write down the question first. So the integral upper bound a is 0, a half e to the power 3x plus x squared dx. And if we take that integral, we will get 10. Okay, so let's start taking the integral. Okay, so a half will just be pulled out. E to the power 3x would be e to the power 3x times 1 over the derivative of the inside, that would give us a third, plus 1 over n plus 1, that would give us 3, x n plus 1 would give us 3, and apply our limits, and we will get 10. Okay, let's neaten this up. That will give us 1/6 e to the power 3x plus 1/3 x cubed, limit a 0 equals 10. This seems like a mundane little exercise, but it will make our work a little easier the next step. So let's apply the limits. 1/6 e3a plus 1/3 a cubed minus 1/6 e to the power 3 times 0 plus 1/3 0 cubed would give us 10. Okay, so this term would be 0. That would just give us negative 1/6, because e to the power 1, e to the power 0 is just 1. So let's write it down. So 1/6 e to the power 3a plus 1/3 a cubed minus 1/6 equals 10. Okay, actually I could eliminate that bracket there. Okay, so let's rewrite it in a little. Let's think about it. We want natural log a third. This is a little bit messy. Let's multiply this whole equation with 6. That would eliminate these fractions and make it a little bit easier. E to the power 3a plus 2a cubed minus 1, so minus 61 equals 0. Okay. Now we are going someplace. I can move these two terms over to that side. So e to the power 3a equals 61 minus 2a cubed. And that is what I have inside my parenthesis there. So I'm really happy. I'm excited to finish this question off. Take the natural log on both sides. So natural log e 3a equals natural log 61 minus 2a cubed. Use my power rule, and we know that natural log e is just 1, so we have 3a equals natural log 61 minus 2a cubed. Divide by 3, that gives us a third. A third natural log 61 minus 2a cubed. And we are done with that one. I'm happy. Okay, so question 7a or 7.1 is done. Let's move to question 7.2. Now they ask us by calculation, show by calculation that this value of a lies between 1.0 and 1.5. Okay, this was what they've given us. A equals 1/3 natural log 61 minus 2a cubed. Okay, by calculation, so we need to create an expression by moving all the terms to one side to show that there would be a change of sign. So firstly, let's see the function a on a natural log and an a-axis would be a continuous function. It's a straight line. This is a natural log function. And we know that it will look something like that on an axis. And this is continuous between 1 and 1.5. So therefore, we can assume that there must be a change of sign to show that there's a root in between. Okay, so a minus 1/3 natural log 61.2a, 61 minus 2a to the 3rd power. So now we're going to state when a equals 1.0, so we'll have 1.0 minus 1/3 natural log 61 minus 2, 1.0 to the cubed, and I can get an answer. Let me write it here underneath. Okay, that would give us, let me quickly do that, negative 0.359. Okay, and then we can also state when a equals 1.5. Let me move it up so that you can see. So we'll have 1.5 minus 1/3 natural log 61 minus 2, 1.5 cubed. And I can do that, plug that into my calculator, and I get 1.687. Okay, good. So there's 3 things that we have to state. The function is continuous between 1.0 and 1.5. Okay, so the function is continuous. Okay, so the next point is there's a change of sign. Okay, there's a change of sign between 1.0 and 1.5. Thus, there must be a root. And 1.5. Okay, good. And that concludes question part 2. Let's move on to part 3 of question 7. Okay, now use an iterative formula based on the equation part A, or part 1. So A equals 1/3 natural log 61 minus 2a cubed. Okay, so we need to create an iterative formula here, and then find the correct value of a correct to 5 decimal places. Okay, so a n plus 1 equals 1/3 natural log 61 minus 2a to n, and that would give me my iterative formula. So I've created the iterative formula. Now let's see, when a equals 1.5, so you could start with 1.0 as well. I prefer to start with my upper bound. I just found it easier. We can say that A0 is 1.5, so A1 would be, now I'm going to plug 1.5 into that space where there's an A. I want to show it to you on actually on the calculator, if you don't mind. Let me just plug that in. 1/3, and then we have natural log 61 minus 2 and 1.5, close my bracket, cubed, and close my bracket. Okay, I get an answer. Okay, 1.33 and 1/2, and we need to write this iterative formula correct to 5 decimal places, so 1.3312, 1, 2, 3, 4, 5, and 1 little 0. Okay, now for the next iterative question, I'm going to go back into my equation there, instead of putting the 1.5, I'm going to press answer. Okay, from there onwards, the only thing that I need to do is press the equal button, and that would give me my next iterative. And let me write it down. So A2 would be 1.343446, correct to 5 decimal places. Good, so I just press equal, and that will give me my next iterative. So A3 be 1.34268. A4, and I just press equal, 1.34273. Okay, and so on. So we can quickly do that. A5, 1.34273. A6, 1.34273. A7, we get somewhere here, 273, and I'm really excited because we are actually done with that one. We've got it. It doesn't change at all. It didn't change for the last 3 values, so correct to 3 decimal places, as they asked us. Yes, to find the value of A correct to 3 decimal places, 1, 2, 3. So my A value would be 1.343, correct to 3 decimal places. Good. And that is, we're nearly done. Only question 8 to remain. Okay, let's start off with question 8. It's a fun question, a little bit more involved on it. Okay, so they give us a diagram. Let me show you the question. They give us a diagram, and then they give us shows the curve, and this curve is tan x cosine 2x, and it's only for a small little interval between 0 and a half pi. And then they ask us, they tell us some information. They say m is a maximum point, okay, and then we've got to find the derivative, but the derivative have to be in this form: 4 cosine squared x minus sec squared x minus 2. And then for the last part of this question, we have to find the x coordinate of m, giving our answer correct to 2 decimal places. So let's get going there. So my first bit is just to write down this expression down. Y equals, or equation, tan x cosine 2x. Okay, and we've got to find the derivative. this is a product, tan x times cosine 2x. So dy dx will mean that I need to take the product. So it's a first times the derivative of a second. That would give me negative 2 sine 2x. It's the derivative of the outside times the derivative of the inside. The derivative of cosine is negative sine, and the derivative of the inside is just 2, plus the second times the derivative of the first, and the derivative of tan is sec squared x. Okay, good. Now let's write down what we have. I know that this I can change, that I can change. So, and I know tan x is sine x over cosine x. Sine 2x is 2 sine x cosine x, and cosine 2x would be, let me just check, 2 cosine squared x minus 1. Okay, good. So let's do the substitution there of all of those to make our function easier. So that's going to be tan sine x over cosine x. Okay, and we can actually move this over to the front. So let's do that, negative 2. And sine 2x would give me a 2 sine, or sine 2x would give me 2 sine x cosine x, plus that would give me 2 cosine squared x minus 1 times sec squared x. Okay, so quite a bit to go in there. Okay, let's see. Cosine x and cosine x will cancel out. Negative times a positive is a negative. 2 times 2 is 4. So, and sine times sine would give me negative sine squared x. Okay, let's distribute there. Plus 2 cosine squared x times sec squared x, negative sec squared x. Okay, good. So we're moving on nicely. Let me just check that the signs are correct and I haven't made a single error. Okay, it seems right. We don't want sine in our answer, so we know that we have the Pythagorean identity that says sine squared x plus cosine squared x equals 1. So sine squared x equals 1 minus cosine squared x. Substitute that in there. So we will have, okay, negative 4. So negative 4, positive 4 cosine squared x. Okay, so I just multiplied this with this term over here, or with a negative 4 to substitute. Now, the inverse of cosine squared x is sec squared x. So actually there I have cosine squared x times 1 over cosine squared x. And we know that would be 1. So we only left with plus 2 minus sec squared x. Okay, for my last term, that is over there. Okay, so just substitute that. Okay, now let's simplify because we've done all the hard work. 4 cosine squared x minus sec squared x minus 2, and we have put it in the form that they've asked us for. So this is the derivative, dy dx. Okay, let's move on to the next one. Okay, let me just get some more clean paper. Okay, so let me write down the derivative. So dy dx equals 4 cosine squared x negative sec squared x negative 2. So we stop there with question 8. The next part of the question is, hence, find the x coordinate of m. So we know, what do we need to do for m? M would be where dy dx would be equal to 0. Okay, that is what we know about m. M, that is the, because they say it is the maximum point, m. Okay, so let's put the derivative equal to 0. 4 cosine squared x minus 1 over cosine squared x, because I said sec x is the same thing as 1 over cosine x, minus 2 equals 0. Now multiply this whole thing with cosine squared x. Okay, so that will mean that I have 4 cosine, so that didn't look like a squared x. Let me just rewrite that. Cosine squared x. Okay, 4 cosine to the 4th power x minus 1 minus 2 cosine squared x equals 0. This looks like a quadratic. Okay, so 4 cosine to the 4th power x minus 2 cosine squared x minus 1 equals 0. Definitely quadratic in nature. So let y equals cosine squared x. That would give me 4y squared minus 2y minus 1 equals 0. Okay, good. I tried to factorize this earlier, and it seemed to be quite hard to factorize it. So I used the quadratic equation and just solve there for y. Y equals negative b plus or minus the square root of b squared negative 4ac all over 2a. So I found, using that, substituting the values of a, b, and c into this equation, I received y equals 0.809 and or y equals negative 0.309. Okay, now but y isn't what we started off with. We started with cosine squared x, so cosine squared x equals 0.809 and cosine squared x equals negative 0.309. Take the square root. We cannot take the square root of a negative number, so this one would be extraneous. Okay, that would give me cosine x, if I take the square root, plus or minus 0.89945. Just put in a few more decimal values there. Take the inverse, so cosine inverse of 0.89945 equals x, and I found, be careful, your calculator has to be in rad, because your limit, when they started off with your question, let me just remind you, your limits are in terms of rad, so between 0 and a half pi. This is important to remember. And then my calculator is in rad, so 0.45, correct to 2 decimal places. I can do the same thing for the negative, and that would give me a negative answer. That would not be the required interval. And yeah, there's not much more that we can do there. That's the answer. Good. And we are done with this paper. I'm quite happy. We've done it in like 47 minutes. You still have half an hour left to continue and look at your problems. And obviously, exam, you don't know the problem beforehand, so things are a little bit tighter, but I'm sure you'll manage. Okay, good. See you on Monday. Please complete this paper, finish it off, bring it completed on Monday to class. Thanks. Goodbye.